Class example 2.14 is a great chance to put your graphing calculator away and work through the question conceptually. Here we're given 4 polynomial functions, a, b, c, and d, and we are given their full equation, but I will say that I can imagine another version of this question in which some of the coefficients were not numeric. For example, in part A, instead of having x to the 4 minus 2x cubed minus 7x squared plus 8x plus 12, maybe it would say y equals x to the 4 minus bx cubed minus cx squared plus dx plus 12. So what we really need to look at here are the leading coefficients, the degrees, and the constant terms, which will determine some of the key characteristics and allow us to determine which function is associated with which graph. So let's start with letter A. We see here that we have a degree 4 polynomial function, so it's even. We also see that it has a positive leading coefficient of positive 1, and so right away we can determine that this graph will not be graph 3 or 4. We know this, of course, because an even degree polynomial function must have both arms in the same direction. Now, between 1 and 2, they are both even degreed. They're both degree 4, it appears, and they both have positive leading coefficients. So how will we tell them apart? Well, we could use the x-intercepts, but that would require us to use our graphing calculator and do some calculating. Instead, let's just have a look at the y-intercepts. In graph 1, we see that the y-intercept is negative because it's below the x-axis, and in graph 2, we see that it's positive. Well, the function given to us in part A has a plus 12 as the constant term. That means that its y-intercept is plus 12. That's enough for us to determine that function A is associated with graph 2. Why don't you take a minute to try the other 3 functions before clicking through the animations? For example B, we don't even need to consider the negative y-intercept here. The fact that this is of an odd degree and that it has a negative leading coefficient is already enough for us to determine it's graph 3. Graph 4 is also odd, but with the positive leading coefficient, and guess what? That will be part C. So again, notice we've really focused in on just the leading coefficient, the degree, and the constant term. Now, all of these functions were given in standard form, meaning in order of decreasing degree, which is helpful. And it's possible that it's not the case, but with that in mind, we are just completely ignoring all terms except that first and last. So the only option left would be letter D. We assume that it'll be graph number 1, but just to confirm, we see that much like part A, we have an even degree with a positive leading coefficient, but because of the negative y-intercept, we can match function D to graph 1. So hopefully this gives you an idea of how we are analyzing polynomial functions without our graphing calculator. Later, we'll learn skills to factor them by hand so that we don't even need a graphing calculator to find the x-intercepts. But for now, we would rely on our graphing calculator for x-intercepts as well as local and or absolute min and max values.